All right. So good afternoon, everyone. Sorry for all that scandal there. I'm going to be talking about nickel-based superalloys. So about regarding superalloys, there are at least 34 mixtures of superalloys, and among their properties, it highlights their good corrosion or anti-rust properties and high temperature resistance. That's why most of these materials are used in the aerospatial industry. They are used to develop pieces for parts that need to be synced underwater in salty water, or working in under high temperatures. So among their typical applications, we find fuel nozzles due to the highly resistant temperature, jet engine parts, or submarine auxiliary propulsion motors. So there are a lot of different nickel-based materials. Two trend marks are Inconel 625 and Inconel 718. That's not the generic name, that's the brand. Um, and what I wanted to show with that graphic is how steady still the properties are while the temperature increases. Um, Okay, so that's a table that I found with I mean, it's a compilation of different tables where we found the material properties obtained through the method of powder injection molding, selective laser melting, the nominal data, and the standard. A lot of the manufacturers refer to the properties that they provided to overcome or be better than what the standard established, the ASTM standard. And that was also something kind of surprising to me at the beginning, that the properties obtained through the additive manufacturing method would be higher in some points than those properties obtained through or the nominal data. Like, for instance, the yielding strength of powder injection, it's almost twice as big as the nominal data. So one of the manufacturers that I found was electro-optical system, which is set in Germany. I found a lot of information of different manufacturers, but it was incomplete. Even though I didn't find a reference to this, I'm guessing that it's because they work with military equipment and technology that it's not yet developed to the market, so they are not releasing that information. And for instance, some magazines redirect me to Arkham, that they were working with Inconel, but in the Arkham page they didn't advertise that. And one of the materials that they produce, besides aluminum, cobalt, chrome, stainless steel powder, it's nickel alloy in 625 and 728, which is the equivalent, almost the equivalent to Inconel, but since it's a trademark, it's different. And these are some of the properties that they advertise. One of the things also that they mention is that there's no much of a difference between the directions in which the tensile tests were applied. So in the X and Y axis, the properties that they obtained were very similar, with a less than a 10% of difference with the numbers that they obtained in the Z axis. So one of the case studies is this is one of the pieces that this manufacturer produced for a manufacturer called Morrison, which is involved in the aeronautic industry. It's a stator ring made from nickel-based superalloy in 7718. It's used in the design phase of the aeronautical industry, not when they are passing to the massive production. And in this case, additive manufacture was an advantage for them, because in a really short lead time they could obtain what would be a piece with the real properties for the final piece. So the the first case study is called Modeling and Experimental Validation of Nickel-Based Superalloy Inconel 625 made using selective laser melting. So in this study, this researcher employed different conditions, different variables to produce the same part, and then they perform the analysis on the final part using also two different size powders. One of it was of 20 microns, and the other was of 40 microns diameter. So one of the conclusions that they got is that the layer thickness had a big effect on the overlapping of the lines, melted lines that the machine produced, and that had a direct effect on the density of the final product and the mechanical properties. So those of the some of the uh, variables that they used were 195 watts with a scanning speed of 800 millimeters per second, and so on and so forth. Sorry, and the second research study is called Numerical Modeling of Microstructure Evolution during Laser Additive Manufacturing of a Nickel-Based Superalloy. So what these guys were trying to do was basically develop a model with a FEM techniques to understand how was the solidifying process in the melting material. So they could analyze better the crystallization and the grain formation of the structure. And what they came up with was a model that could predict really well the effects of temperature and cooling rates in uh, the structure of the final product, and they compared that to uh, real samples. And the advantages of this is that they could, using this model, better predict or establish methods for future solidifications. One of the, these are my references.